Okay, so here's the equation. Everybody sees how to solve that, right? Well, if you're an MCR, you did, so I'm going to go through this quickly so you don't have to, but it won't hurt you to review. The main thing, photobomb, good one. Main thing, I want you to see is the process. Okay, so you look at this equation. Where's your variable? Well, I made it obvious because I circled it. Your variable's t, and that's obvious, right? But that's the first thing you want to do. You want to identify your variable and see where it is in the equation, right? So where is it? It's in an exponent, right? Now, if your variable's in an exponent, what's that tell you about something's going to happen at some point in the solution process? You're going to have to do a log, right? In what form do you have to have the function or the equation to do a log, to use the logarithm? Well, here's the form. Here's what it's going to be. You're going to be able to reduce this equation very easily, it turns out, to e to the negative 0.07t equals 3, right? Once you have it in this form, you can change it to logarithmic form, and then the solution becomes very easy. Okay? So that's going to be our goal, is to get this e to the negative 0.07t on one side of the equation. We can't apply the inverse function. We can't change to logarithmic form, though, until we have it here. So we're going to have to do other things first, right? Does that make sense? Okay? Even if you're an MCR, you know, listen to what I'm saying, because I'm saying it a little differently than I did there. And if you want to see what I said in MCR, the video will be there. Okay. So here we have the equation. What's the first thing? What's the other thing? Where else is t other than in an exponent?
The denominator? It's in the denominator?
That's it sounded like you said in the thermometer. But that's my ears. I don't have the hearing aids in. Okay. I knew what you said. I just wanted you to repeat it just to make sure you weren't confused, because this is a physics lab also, and there are thermometers in it. Okay. Well, very good. Okay. So here we have it, right? So now, what's the obvious thing you need to do to both sides of this equation then? Should be obvious. One of the big principles in solving any equation,
Multiply?
you multiply both sides by common denominator, right? Now there's only one denominator, so it's really easy to find the common denominator. That's it, right? What you got is it. So we multiply both sides. Now, this process that I described here is identify the variable and mark it. Where is the variable? You notice it's in the denominator and an exponent. What to do? Do you do a log? Do you multiply by the denominator? Those are the two things you do, right? If your variable's in an exponent and if it's in a denominator. Well, you really need to multiply by the denominator first, because in order to apply the log, you have to have it in this form, and you're nowhere near that. So hopefully by multiplying both sides by the denominator, we're going to find it feasible to get into this form. So we do. Multiply both sides by the denominator, and here's what you've got, right? Now, take a look. Here's the equation. You don't have to copy it down. It's going to be in the internet. Pay attention. Okay? Look at the equation and tell me. Don't anybody say. Everybody write down what you're going to do next, because there are two possible choices, and they're both good choices. Just as long as you don't do what Candace did.
I did it right, though.
Yeah, you did. And that was a good thing to do. That's really the best thing to do. But I went with the next best thing, because there was something I wanted to illustrate. So see if you chose what Candace did or what everybody else did. Okay? So what are you going to do? What are your two choices?
Use the distributive property?
You could use the distributive law, which is what I did. Or what?
divide by 50?
You could divide both sides by 50, right? Which is what Candace did. And that's actually a little quicker. So great minds, whatever, how many of us have you thought about divide by 50? Okay?
Great minds think alike.
There's nothing wrong with either way. Distributive law is very obvious,
Or is this just better?
okay?
You still gotta divide.
And it really doesn't make much difference, okay? Okay, so, you could divide both sides by 50 or use the distributive law. I chose to use the distributive law, and that step is obvious, and we get this, right? Now, once we're at this stage, it gets pretty easy, okay? What are we going to do from here? If you're an MCR, don't answer, but somebody else tell me, what's the obvious thing to do next? Actually, two things you can do, but one of them is clearly better.
Minus 50.
Yeah, subtract 50 from both sides, right? Because we're trying to get down to e to the negative 0.07t so we can apply the inverse property, the inverse function property, right? So we subtract 50 from both sides, and what we get is obvious. Okay, now we're almost there. What's the obvious thing we're going to do here? Divide by 100, right? Now, we don't subtract 100, do we? Because 100 is multiplied by the e to the negative 0.07t. We can't undo a multiplication by subtraction, can we? The inverse operation for multiplication is division, okay? So we get this, and the rest of it is history, right? Now, is there any step of that that you don't know perfectly well how to do? Okay? It's an unfamiliar problem, but you know everything you need to know in order to solve it. And many of you, I think, if I'd have given this as a quiz, would have solved it, but I don't think the majority would have. Okay? I could be wrong. And mostly because we haven't solved that many equations, and we've never solved an equation of this nature. Okay? So I think most people would tend to get confused at one step or another or make a mistake somewhere. So we're trying to eliminate that because equation solving is a big deal.
So we did,
Okay?
we basically did 2 chapters.